Good afternoon, everyone. Hopefully you're all doing fantastic. Let's just share this real quick. Yes, so as the title suggests, we are actually doing something a bit different today. So we didn't manage to add forces yesterday to our renderer. I'll just pause the music for a moment and start the timer on my end so I can make sure I'm productive. Okay. Right. So this is where we got up to yesterday. Oh, I don't have the chat open. Let's just get that open. So while that's compiling, I'll just get you guys open. Okay, so we got this morning. Hi, Revere, how you doing? So now we have a basic kind of audio system going on. We've moved the player down a notch. We can actually see what's in front of us. There's laser sound effects. This all is happening. We got this working with our new system. Now this isn't truly a force. This is just I'm moving in the negative Z direction based on the camera. But it's getting to the point now where we're going to have to start thinking about 2D rendering. There's enough in this to start making a game or so. Let's turn this. I think it's a bit loud. So that's the music. So there's enough in there to start adding something to the game. You know, adding some stuff. I don't know what we're gonna add yet, but we need to think about 2D rendering for various reasons. The most obvious one is a menu, because it would be a bit impractical to give someone an executable where they're immediately driving forward. There could be a rock right in front of them, and yeah. So we need like a way to allow people to start the game at their own terms when they actually need to. At the very least, we could have. We obviously want more in our game engine than just the start menu, but that's a start. That's like the thing I want to do as well. Just so. I'm thinking about adding like a gun. I don't know if we'll end up doing this, but if we're gonna have a gun, we need like a red, like something in the middle of the screen, right? So like this, like where my mouse is, we need like an X, kind of like Minecraft has. So you can actually see if we do shoot stuff, where your lasers are actually heading, because at the moment the character model is off screen, you know, down on purpose, so you can actually see what's in front of you, so you don't end up like, you know, somehow seeing something that's too small, that's constantly covered by your rocket ship. So yeah. Okay, so 2D rendering. The thing is with a 2D renderer, to do 2D rendering in the way where we can layer textures on top of each other. So this is an older engine of mine. And I'll just run I don't know if it compiles, so I'm just going to grab this. So what this is doing is it's rendering text, like literally I've typed this out. This isn't a texture. So this would be the main menu, right? But anyway, we have this guy. And as you can see, this dwarf character is able to be in front of stuff. Which is fine, right? But to actually pull this off, where we can layer multiple sprites on top of each other, we need to have a system where we're actually rendering in 3D and we layer things up in 2D based on the position coordinate. Now, this is done in a 2D game engine, right? So this is like really simple. We just do a view projection matrix, and we just kind of fake the distance. Basically, we just set it up as a, I don't know, a really, because this is cleared from, furthest thing away is 0, and the closest thing to us is 1. We just say like 0.5 for like this thing, and like 1 would be this guy, which is right next to the camera. The problem with our engine right now, which I haven't quite managed to pass through yet, is the fact that, okay, so we have a 3D renderer. Now if I put something in 2D at a random distance in the Z value, is it just going to be floating like a straight rectangle just floating in space rather than following the camera the whole time? So that's the point, right? We effectively want a rectangle to follow the camera all the time, kind of like the player right now, but at every single angle, no matter what we do. And also, we're going to have to disable the camera at different points, so that won't be too much of an issue, but still, we've got to be careful that we don't render a 2D object in 3D space and have it stay there. So yeah, that's the thing right now. Yeah, so surprise, surprise to anyone who may be watching. Most modern game engines that render in 2D actually render in 3D. It's also like if anyone was wondering like how do games like Unreal and Unity like allow dynamic shadows to cast on 2D sprites? That's because they're not actually 2D games, they're actually 3D games, and you're only seeing one side of the game in 3D. So yeah, that's what we're going to be doing today. I have a list of things that we're going to try to achieve. First is to render a quad on the screen. We're just going to pass in the vertex attributes. Yo, the big loose goose. How you doing, dude? We're basically going to add we're making a 2D renderer, so we'll see how far we get down this list. So the first list is to render a rectangle or something. It doesn't really have to be a rectangle, but I really hope it will be. I thought this was an orthographical projection, but I actually need perspective. Perspective, projection, and we kind of need to be careful here with the camera, right? So this is going to be make sure the quad always stays where the camera is looking. So that's how we're going to fake 2D. We're going to only use an index draw call here. The next step after that is, instead of having the vertex attributes hard-coded in the shader, which will just make things easier to start with to test all this stuff, then we'll move on to instancing, where we instance those rectangles. Effectively, I want to replicate what the Hazel engine did, or my engine. This is effectively a clone of the Hazel engine, I'm not going to lie. I wrote this a long time ago. If you've written the Hazel engine yourself, you'll be very familiar with this code base. It's a little different, but it's not that different, really. So effectively, what this engine does is it has a static object here with a struct that contains basically a list of rectangles or quadrilaterals, and that just builds up a buffer. And based on that, we can count how many times we call a draw quad function, and each time we do a draw quad function, we increment the instance variable by 1, the index variable by 6, because there's 6 indices, and yeah, then we just do everything else. And obviously we want to do this with a buffer device address, because that's what we've been using up until now. So that means we can actually use instancing and R shaders. Just for people who are wondering, this whole engine, this thing here, this is written in OpenGL. So some of the stuff will not translate at all, but what we're going to do is just take what we can, the architectural ideas. I'm not going to take over the many layers of abstraction that this engine has. Like, it has too many layers of abstraction where it tries to basically have an agnostic API. I'm only going to use Vulkan, and I'm committed to that idea, so we don't actually need to do anything else. There's a bunch of other stuff in here that I just don't want to do. I think this is maxed out to 32 textures, which is kind of interesting. Back in the day, I don't think this was done. This was done without bindless textures. So you bound 32 textures, and you hoped that you disabled the textures. But anyway, yeah, we're going to write a shader. We're going to do We're going to have this idea of having a struct that increments, and we're going to basically set our max draw calls, our max instancing to 20,000. So we'll instance about 20,000 rectangles. So effectively, all our UI is going to be in one draw call. If we do that, finally, then we're going to make sure that the slightly more advanced, we'll get this very quickly. If we get number 2, we'll get number 3 basically for free, but we want to make sure that we're not just drawing a perfect square. We want to make sure that we can fold the rectangle into whatever, a really thin one, a really long one. And then we want to add texturing to that rectangle with our bindless descriptor pool. Add that to the quad. We're not going to worry about text yet. That's going to come later. We need to basically, before we even think about a text that we're going to render from a TTF file or something, we need to be able to render textures, and we need to be able to handle alpha components. So if I bring this up again, like this is on a rectangle, but like obviously this part and this part here are transparent, and that's what we're trying to aim for today. We're trying to aim for something. Well, I don't know how far we'll get, but that's the beginning, right? That's the beginning. We'll see how far we get. So yeah, that is what we're going to be doing today. So hopefully you're all up for that, and yeah, let's dig into this. So the first thing we need to do to begin is start building a graphics pipeline again for a 2D renderer, and we also need shaders to do that. So main is getting extremely messy right now. We have 3 graphics pipelines, and they're all just kind of sitting in main. I think after this point, I need to seriously think about moving things around, because right now we have an extreme amount of, I don't know how to describe it. It's not tech debt, but things just need to be cleaned up, right? It's deliberately easy to edit because we need to be iterating, but because we've managed to achieve so many things recently-ish, we need to actually think about moving this into a place that actually makes sense. So anyone who looks at my source code, or myself in 6 months, I guess, doesn't look at main and go, what the hell's going on? Right. So yeah, let's start some music. And again, indeed, yes, everything needs to, okay. Everything in Vulkan unfortunately requires a graphics pipeline, no matter what you do, unless you do something like SPLV reflection, but we're going to avoid that because I could go into that, but I'll stop yapping and just start writing a graphics pipeline. But yeah, feel free to ask me about why we need so many graphics pipelines if you're interested. I just thought it might be a bit interesting if I just crack on. So the first thing we need to deal with is, where does the code begin and end, right? So the first thing I need to do is add a 2D graphics pipeline. So again, this will be fake 2D. This is going to be a 3D fake. We're going to be faking 2D, which also has the benefit of helping us implement some of, I don't know how far we'll get through this. Sorry, a bit yapping again, but we might, this is like the predecessor to having billboards in our engine, because effectively we need to, that's part of the 2D renderer, but it just has a different application. Anyway, okay, so what shall I call this? I can't call it 2D because you can't start a variable with 2. I just have to go pipeline 2D, I guess. And what do we need here? It's descriptor sets. We'll worry about buffers later. Again, this is going to be as simple as possible right now. We're going to write all our data into the shader. Because I just want to see if it's... we want to get the camera working first. But we do need actually a graphics pipeline that supports... Sorry, a descriptor set that actually has the camera in it. And... Yeah. Billboards indeed. So there's a couple of things I want to do with that, but that'll be spoilers, and I don't like to talk about things unless I'm actually doing them. But I've got some cool ideas for that. Okay, so But yeah, first is all the 2D rendering. Okay, so how does the camera... I should just remind myself quickly. How does the camera coordinates actually get to the shader? I think this is just done with a... Yes. So we need to set up this to link up, I think. View projection and view projection. This is a bit scruff. I think I need to get rid of this and just have either rather than both. But anyway, yeah, so this basically needs to be set up as the... So this is done as part of the buffer device address. So let me think, right? I just want to I want to write this code before we start. The plan is to obviously write this code, but I want to set myself up for success rather than just doing it as fast as possible. So we also need to have another buffer device address that takes in, yeah, this basically. We want this in our second shader. So let's write the shader first, because the shader's going to dictate the graphics pipeline. That's kind of how it works anyway. But what should we call this? Can you? Yeah, you can call things 2D, right? So our 2D shader. Again, I have no reason to call it anything else, so I'm just going to call it that. So we're going to make the two. So yeah, like I said, this engine's called the Tempest. If you actually want to look at the 2D render. OpenGL style. That's also on my GitHub, along with the Void engine, which is the one we're working on. So yeah, let's dive into adding the shaders to the right place. So this is going to be a very simple 2D shader dot vert and frag. So again, we're going to rewrite the... I almost actually don't want to do this. I think I might combine step 1 and 2 together. Because we've got to... If we're going to use buffer device addresses straight off the bat, then that makes... I don't have to modify the graphics pipeline after the fact. So yeah, I think I'm going to do that. Let me... So, oops. Control V. So yeah, the shader's going to dictate what we're going to be doing today. So again, this is going to be a very simple shader. There's not going to be anything interesting here, but it's going to help me think through what we're going to be doing. So it is necessary. Right, where are our shaders? Oh, I think it just picks it up with a recursive blob. So let's just do this. Yeah. So yeah, after this we'll... Oh, yep. Yeah, don't take the risk of talking about things you are doing. Yes. Oh my goodness, without a doubt. I can totally empathize with what you just said there. The big goose. The big loose goose, honestly. It's one of those things where you think, oh, I'm really excited about this idea. I would love to talk about it. And either you don't want to do it anymore, or you don't end up implementing it, or something comes up and it's just like, oh, that's not good. I feel icky about it now. So yeah, let's... So... It's been a while, so... I'm also trying to keep the scope of the game very small. I was thinking about this yesterday, where I was going to the gym today, and I had like so many ideas. I was like, oh, I could do this, and I could do this, I could do this, and then I could expand the game in this way and expand the game in that way. And I just thought, I've got to be careful here, right? This might turn into a multi-year long, maybe a decade long project if I'm not careful. Very, very quickly, especially if I'm just working on this by myself, and that might not be practical for the long term. But anyway, so I'm restraining myself quite heavily here to not. Okay, so we need all these. I don't think we use this. I don't know why this is here. Yeah, I'm trying to restrain myself very heavily here by not you know, getting too excited by things. Staying disciplined in my own mind, I guess. So let's position. So we actually, I believe we want everything the same, but we just want different data, right? what's scene buffer again? Scene buffer reference. What does that do? That takes in the... Yeah, we literally want the same scene data. I mean, I don't mind taking years on a project, but I've also got to accept that if I do that, then I probably will have to delegate more than I would like at the current stage anyway, because I haven't released anything. So there's no income when it comes to game development, which is... Do I use these? Hang on. No, these are output variables. So we need to decompress the results. Okay, let's just take all this, because this is actually going to be extremely similar. Oops. Whoa, 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 whoa. But we're just not going to have some stuff in here. Effectively, we're going to simplify. So we don't need tangents. Obviously, we don't need bitangents. We don't need anything like that. But other things, yes. So color and position. And obviously, we need the padding. Now... we do need this for the our camera that we're going to be using, which is going to be different again. We've got to not do what we're doing here. This is a 3D use of this. Okay, so obviously we do not need normals, as far as I can tell. I don't plan to have any 2D rendering. Again, this might change with billboards, but and color, right? I think yes, our color being part of the instance renderer is kind of quite nice, actually, if I can get away with that. GL instance. We don't need tangents. That would be not interesting at all. So that means we don't want to worry about this. Now, as far as I can tell, we can have the same pointer to data and everything like that, assuming that we still have something in here. I could be completely wrong here, but I think I can get away with doing this, right? But we have a... okay, so this is not going to fit. If we're going to do that, we need... so that is a float, that is a float. Yeah, so we need a... to pad this out properly, we need a PW, which we're never going to use. So this is just padding. I could actually add it here as float pad. So this is 4, 8, 12, 16, and then, yeah, another, so that gets to 20, which is fine. Vertices, position. And yeah, this thing is fixing really. Okay, so this is the thing we don't want. I don't think we need a model coordinates. That's going to be part of the vertex attributes, I think. Let me think. I think... let me look at another shader for real quick. What is the model in this situation, right? Because if this is per instance, we could... yeah, like that sort of... interesting, this is not padded. But anyway, I don't think it's an issue. I think we can get around this. Interesting, we have two models. What's this for? Yeah, we have a model, but... is this even relevant? What's debug model doing? Okay, so we'll just compile that and just see what it breaks. Okay, yes, NX... oh, yeah, okay, so that's the 2D renderer. Let me just finish up things there, but I don't think we've got... yeah, we don't need normals. And I think that's good. For a clean compilation, it's not going to be what we're going to be using. Yeah, okay. So that was... yeah, this is completely redundant. That was from something I was trying to do that I don't think worked. Okay, so scene data. We're just going to use the same stuff. We have models in here. I do like this better in my version, because that means we can have the transform of the... so we're gonna throw this in here as well. So this is the transform, right? So if we're gonna place a rectangle in a different place, we need to have that. So I'm gonna call this transform, so it's a bit more clear because there's no model in. Hang on, model. What is position of model? Hang on, what's the difference? Okay, for now I'm just going to assume that we can put model position and or scale in this. Yeah, let's simplify this. I might have got this wrong, but yeah, we don't want that. We don't want to output a tangent. We don't want normal. And obviously this needs to be changed to 1, 2. What else? Okay, so we have position, which is fine. Per vertex. For index. Then we want a view projection. Scale. We do want the color to come through because that's going to be quite useful. And I think that's what our shader needs to be. We might be able to get rid of the padding, but I think because I'm going to keep this here for safety. It's possible that in the debug render, because there's nothing else after this, then we don't have to worry about the padding. Whereas, yeah, padding has screwed me up in the past a lot, so let's change this as well. This is kind of scruffy. I've got to decide. Oops. Let's quickly fix some like stupid inconsistencies, which aren't that bad. It just like help reduce the cognitive load when we're looking at our code, right? So let's put the what is it called? The scalar block layout in here, which is important, so we don't end up anything. So the core shader is going to have the same change, which is going to be quite trivial, but I'm going to have to rerun our code after this just to make sure I haven't broken anything, which I don't think I will, but yeah, if everything's aligned like this, it's easier to read. Don't think we need that. Hello, Ratchet, how you doing, dude? Hope you're having a fantastic day, whatever you're up to. Just cleaning up some code, and we should be good. Just making it easy to read, effectively. Yes, so this is the thing where we've been inconsistent in a couple of places for our buffer device address defined things. Again, I forgot the name. I haven't taken notes on the actual name. Anyway, so yes, we have position. Okay, why is there a texture in here? Like, I don't understand this. Do we use this? What are you doing today? I'm playing video games, procrastinating. I swear, I'll get back to working stuff. I see. Yeah, I know how it feels. I've been throwing recently. I've been working as hard off stream. We are adding a 2D renderer, aka a 3D renderer that always looks at the camera, as you're probably already familiar. And I'm just going over my shaders right now because I want to write the 2D renderer shaders, so that dictates the graphics pipeline that we end up using for our Vulkan. And yeah, the goal is to have a textured quad that has some alpha texels that get excluded. That would be cool. So that's, I don't know if we'll achieve that today, but I don't think we need this. I don't know why this is here. And I'm just looking over my shaders because I haven't actually some of these I'm putting like random stuff in here that I don't understand. Yeah, this is going to be just called pass. So yeah, trying to reduce the cognitive load of what we're doing here. Whoops. What was possible then? Hang on. Where's this come from? Oh, it's come from there. Okay. Okay, that's important that I don't get those mixed up. Yep. Yep. So we know they're completely separate now. There's no debug stuff going on there. It's kind of stupid. Okay, so now it's possible I've completely broke something, but I don't think I have. Apart from, yes, stuff in the 2D renderer, which we haven't finished. Kind of. That's going to be a component of this renderer, but not. We're just going to try and add a rectangle on the screen. For basically UI and like a menu. We need some like 2D elements to this video game that I'm trying to write. So, but that, yes, we will be doing billboards at some point in the future. But I don't know when, and I don't know what we're going to use it. Well, I do. I personally know what I'm going to use it for, but I don't want to talk about what we're going to use it for until I'm actually doing that. Yeah, so I know the shaders are slightly different, billboard stuff, but because we're going to have to use a 3D camera anyway, I'm seeing if we can use both the same thing. But we'll see if it's even possible first, right? So the first thing that we need to do is write our shader in a way that I think I want. Reusing as much as we can, so we need position, which is the vertices, and we need the texture coordinates, and we're basically going to ignore the texture coordinates for a minute. We have a view projection. Global scale we do not want. We're not going to be scaling anything by global amount, I don't think. That's the position, so that is the we don't want model here as well. And we don't want global scale. I'm not sure we need this position, but we'll take it anyway. Really, we just need color and text chords, because we multiply the texture by the color and then we get whatever. But for now, we just need the position and the actual vertices, so the vertex positions themselves. I think we're good here. This is exactly what I would want to do. So it looks like we need 3 buffer device addresses, no descriptor sets, and the same push constants, which is handy, to reference these buffer device addresses that we're going to stick on the GPU. Which that simplifies our graphics pipeline considerably, because it's exactly the same as the setup-wise, at least, as the debug renderer. But anyway, let's oh, I didn't even check if I did I break everything? Okay, no, I didn't. Let's turn that music off, because I don't know how loud it is really. So oh, and for those who have just tuned in, we did actually get the music working. I was cut off yesterday. I wanted to keep going. I was quite disappointed in the fact that I couldn't keep going, but it was just too late. I had to, because I'm on the kitchen table. Food needed to be put on the kitchen table, and I got kicked off the table. Pronto. Yes, never mind. It is what it is. Anyway, so what are we trying to do here? We're trying to disable the... Where did I put the audio, actually? I think I put it in scene. What did I decide that I want to add the audio? Okay, I think I just stuck it right at the end of the audio setup code. Yes. Okay, so we're just going to disable these for now. So we shouldn't get any audio clashing with the music. Cooking with escape point. Yeah, that'd be cool, wouldn't it? I'd have to learn how to cook first, but the audio system's good. Yeah, we yeah, I'll explain what we did. So I don't know if you were here for it, but we basically load all the audio assets into 2 different arrays, and we index into those arrays via a enum. We use the stack for loading things, so, and we push and pop from our stack as we do this, so the stack doesn't end up getting too big. Effectively, this is just a big malloc and then we just pop and push through that malloc and overwrite stuff as we need it. I will show you the enum idea. So this was the trade-off I decided to take. So instead of having some kind of map where we have to do a find every single time that we want to run some code, we have this enum that corresponds to the same position in a string, and we then, so when we load like an asset like this, for example, the flying sound, it also corresponds to this position in the enum, and then we just say if we want to actually run this piece of audio, we then just say, okay, sfx : which I'll show you. So this was in here. Let me show you. So if I wanted to play that sound effect, for example, that laser sound effect, then I just do sfx laser, and that just then indexes into the sound effects array. And this is a couple of things that I like. It's everything's just in one contiguous array, which I really like. It's relatively quick. It's constant time to actually look up this particular asset, and yeah, it's pretty straightforward. The only downside of this, I know there's a trade-off here. The trade-off is it's harder to add assets to the audio system. It's possible, for example, that I absent-mindedly do like new music, right? And now, right, new music. What? Okay, and I put like this here, like new music. I just say FLAC, right? The problem with that is now this is out of order, right? So so this is now index 1, and this is now this is loaded at index 0, 1, 2. So now everything's out of order. You'll be playing the wrong sound effects. That's the downside of what I've decided to go with. But it's a trade-off I'm willing to take. Everything's just trade-offs, so that's what I did in the end. And it's entity components. It doesn't touch the entities. The entities don't own any audio, based on what you said, by the way, Ratchet. So that's what I decided to do. I'm not well versed in IDEs, as I've mostly used NeoVim in the past and only recently started to switch to Rider. Is this code or Codium? That logo on the left. So this is Visual Studios, written by Microsoft. It's currently using the Visual Studio. Ratchet's already answered this, but I'm using the MSVC compiler, the notorious MSVC compiler. Yeah, there's like Ratchet said, it's not a perfect API. There are trade-offs here. There is a downside to this. The maximum amount of like I can have like lots and lots of assets, but like if I have like tons and tons and tons in a massive list, that might be something I change later, right? For now, this is fine. It's possible that this gets too unwieldy. But anyway, it's not. I don't think it's bad. I just think it's like I've made some trade-offs. They may not be good. They may not be. They're fine for now. But I just like the simplicity of this right now. So this is the simplest I could come up with, without having audio split up into different arrays or like random MA sound effects in different places. So yeah, that's what I did. Hello, Coding Banana. Hope you're having a great day. Yes, exactly. You got it right there. So yeah, there is a trade-off with this. 100%. Yeah, 100%. So yeah, that's the trade-off I decided to take, and I'm okay with it. We'll see how I feel about that in the future, as I hopefully improve as a programmer. Anyway, so let's dive back into our 2D fragment shader, which we haven't started yet, but this is going to be basically... Okay, it's not going to be that. This is going to be basically the same as the... No, which one do I want to use here? I want to use the... Yes, this is what I want, right? We want to have our 2D renderer be very similar to the renderer in IMGUI, except we want to use... So So we want color, fragment, and position. Do we even use position? I'm probably going to get rid of that. Yeah. Yeah, I don't think we do. So let's get rid of position. We don't actually need to do anything with position apart from set the GL position variable. So that means we can simplify this again. Because that's what we want. We want text chords, we want color, and we're going to send these in. Let's just send these in. So we have a texture ID. I'm kind of curious. Oh, let's put this in. Why do we have a texture ID flat here? Let me just check. So I think... Where does this come from? The instance ID. Interesting. Instance index. I don't know if that's something that we can rely on. But it is interesting, like, how do we send over this variable? Let me see. Oh, great. I'm glad you're having a great day. Oh, I didn't read something. Thank you for asking. Yeah, I'm pretty good. I'm a bit hot, but that's just, you know, this time of year. A bit sweaty. What I do is normally assign values to the enum, so I never have the index problem. Ah, that's a good idea, actually. Yeah, because then it's not order dependent. Although I'll make it order dependent. Let me do that. Yeah, that's a bit of safety, right? Bit of safety. There's no there's nothing wrong with this. Although count is now, we've got to be careful with count, but I'm okay leaving that. Should I say? I might leave it for now. I'm gonna leave it for now. Actually, I changed my mind. Sorry. I'll come back to that. I'll think about it a bit longer. But yeah, let's dive back into this. So we do need to index into a big group, an instance ID. So the instance ID, hang on, let me think about this. So the instance index tells us what the what texture we're using. Yeah, that works because eventually we're going to have instance IDs. So each quad is going to be an instance thing. So yeah, I think I want the same thing. I want the same setup, actually. That's actually really smart by doing that, actually. Yeah, because I didn't think that. I was like, oh yeah, oh, hang on, we haven't thought about buying this. So we want out. Yeah, that's really smart. So we want the instance index. So for each instance index, we're going to have a different texture, which, yeah, makes total sense. This assumes that we're always going to have a texture, which is fine. All we have to do is, for each instance triangle, we need to set... Oh, I don't know how good this is going to be. Let's just say we have 400 triangles and all... Sorry, all quads. Let me just think about this. Let me... so we have, I'm just thinking about texture limits, right? In our bindless texture. Will we be concerned if every rectangle that we put on screen has a different texture? And will that cause issues? I'm going to say no. How many UI elements I'm going to have on the screen, even if I have a main menu up, is going to be... Right, let me look at something, right? We're going to do something a bit unorthodox. We're just going to look at a video game. And I'm going to pick this game, because it's just not tied to any online service. So yeah, now I'm becoming a gaming streamer. But we actually do want to see like a general how many UI elements is realistic So yeah, put it with me for a minute playing a video game. Hopefully that's chill. So this was an indie game that's completely free to play. It's like a card survival game. It's kind of cool. Made by a lot of people at the University of DigiPen. I don't know anything about this university, to be honest. I think it's American. Yeah, that thing. So, blah, blah, blah. So this was made in Game Engine. And what I want to do is just get into a game and just press the... Right, all I want to see is immediately... Alright, okay, this is what I'm interested in. Like, how many... Realistically, how many textures are we going to have on screen? Yeah, I don't think this is an issue at all. Yeah, this is completely fine. This is just text. This is like another... So, music, and this is a different texture. This is a different texture. Even if this is a different texture, I don't think we're ever going to run out of texture slots. If we have like textures all over the screen and stuff. Alright. Cool. Yeah, thanks for that. Gaming streamer for all of, I don't know, 30 seconds. It was a bit loud, that. Sorry, I apologize if it was a bit loud for you. Okay, so, yes, we're not going to worry about the instances running out. Sorry, the amount of textures that we bind. Because although we have bindless textures with an array that has no size, there is technically a size because the descriptor pool is sized by... Okay, so frag color, we need our texture coordinates and our color. I think that's everything. Oh, do we need the other thing? I should be updating this with the fact that I've added an extra cube map here, so we might actually want to slim this down. I want to do the opposite, but yeah. I know we're not going to use these, we're just aliasing these. That's why they all have the same descriptor set binding. But yes, I'm going to worry about this later. Where was the other thing I want? Oh, here it is. I don't know, I think this might just slow the compilation down of the shader itself, so anyway. But I'll leave it there for now because I kind of want to keep things consistent and not break in the future. So yeah, text coordinates and color, and I guess it's 0 doesn't make any sense anymore, does it? So we'll get rid of these. And text chord 0 is for a reference to a GLTF thing. And I want to obviously not have it. So scalar, buffer reference 16 and 8. We don't use 8. And we need the pointers. So, yep, that's about right. We have this twice, which is not good. And let's just make sure the same binding is correct. So texture coordinate is flat. We don't want to interpolate this. And yeah, text chords at the top. Out color, right? Okay, so for so I don't go insane trying to work out how to do textures with this right away. We're just gonna say for now that we're just gonna do color for now, and we'll come back to textures later because textures is a whole kettle of, there's another kettle of fish there that we need to worry about, which is effectively for each time we create a quad, we need to set a 1x1 white texture up. So that means everything is technically a textured rectangle. And if you want to do a, I don't know, a colored, just a simple colored, like green rectangle for some reason, then you actually pass up the white texture and then you multiply by the color, and the texels just that this is white x the color vector. So anyway, we are done here. Let me just compile this. Man, I don't miss... yes, I'm trying to get away from them myself as much as I can, but you can't really avoid it as much with textures. As far as I can tell, at least. Right, so let's just make sure we haven't broken anything. Yep. Yep. Ah, I'm gonna crash. Okay. Oh yeah, that'd be interesting to see. The heaps. I'm gonna completely avoid heaps, descriptor heaps. I'm gonna stick with descriptor buffer addresses with pointers for now, and try to reuse them as much as I can. But yeah, if you've gone to descriptor heaps, that'd be interesting. Interesting. You can. Sorry, I know you're talking to Ratchet, but I'm kind of curious as well. No, yeah, I'm being what is it called? I'm intruding on your conversation, but that's kind of cool that you decided to go with descriptor heaps, and you found it easy to do, because it looked like super complicated to me when I was looking at someone else do it. I was like, ugh, what the heck? So yeah, it's very similar. So we don't want to do wireframe mode, so that's completely irrelevant. We need a 2D shader and a 2D frag with our scratch allocators for sure. Let's say 2D and the hardware has built in for many years. Nice. So it's about, yeah, yeah, me and Ratchet are on the same thing. Hi, hello, the Cap-Chew man. How you doing, dude? Hope you're having a great day, my guy. Pleasure to have you here, and everyone else, to be honest. Thank you for turning up, everyone. It's always nice to have you guys around. Right, so 2D. What else do we need? We need. Okay, so this is the interesting part. How do we do depth with a 2? Okay, so I'm just gonna render like a rectangle, and if it's in 3D, then we'll make it 2D later. Okay, so the first thing I need to do is think about what we end up uploading. Let's see. Let's think about this. So I need to bring up, I don't know why I closed it, but let's bring up the older renderer. I'm learning common coding patterns. Ah, cool, nice. Like you always multiply multiple values by speed in movement actions. Yes. Mm-hmm. Do you think that it's a good way to get better at coding? Yeah. Like anything, like what I would recommend is when you're learning something like that, like studying, and you're finding it useful, coding banana, just make sure you take some notes of some kind in some way, and have some kind of system where you revise it. That's what I think, right? So it doesn't have to be complicated. So what I do typically is I just open up my this is just a, you don't have to use Obsidian, but some days I'll just go, I don't know what I want to do today. Okay, let's read storing booleans out of bound. Read all this. That's like a small note, right? It's not that complicated. Then I'll go back and I'll click on, this is Vulkan, so I'll click on a Vulkan thing. Binding descriptor sets using draw time, right? Very simple. Just tells me what this function does. You know, yada yada yada. And if I want to do a specific thing, then I use I go like to threading, for example. I'm doing a lot of threading, so like, okay, how do you pass in with standard thread, how do you pass in the arguments? So, oh, okay, so it's just like this, read this, you know. That will make you a better programmer faster in the long run. It's slower, you'll learn slower, but you'll forget less. And I think that's an investment that's worth taking, in my opinion. But yeah. Hi, Kalia. How you doing, dude? Yeah, I'm doing good. Just a bit hot, but we're moving along with our 2D renderer today, so that's going to be fun. We've just about started, so welcome. Hope you're having a great day and you're doing good. How's your C++ going, by the way? Is you still enjoying the grind? While I figure out what buffer I want to add, which is good to know. How do I want to do this? So we have position data, which I'm kind of curious, like how does this get created? Yeah, so what I'm going to do actually is I'm going to make a new file. And I'm going to put this in graphics. The first thing I'll put in graphics in a while. And tie all my buffer creation code, my pipeline creation, and drawing with the command buffer kind of in one place, because we need to have a system where we systematically go through our... we need to basically build up the data pair function that I call a draw quad. So yeah, I think I'm gonna do that. Ah, you're doing great. Yep, nice taking notes. Yep, solidifying the fundamentals. No problem. Coding banana. Yeah. Yeah, just be patient with yourself in the long run. That's the other thing. Oh, interesting. So RenderDoc doesn't say it supports descriptor heaps. Oh, okay. Interesting. Sorry, I'm gagging in on your conversation about descriptor heaps. I feel like I need to be told off. Get out! Escape point. No one asked you. I've become my own teacher. Hell yeah, dude. Love that. Right, okay, so we want to have a 2D renderer. So this is... don't want to call it renderer. It's kind of a bit vague. Yeah, I'm going to call it 2D renderer until I come up with something else. That's what I did in the other engine anyway. So I think it's going to be more ergonomical in the long run if I just try to stop putting everything in main when I don't have to. Like, I really don't have to do that. So let's make some new files. Again, I don't know if I'm going to instance this and make it like a huge... Sorry, a singleton, sorry, I meant to say. But yeah, the last thing I put in graphics was... the load GLTF code, which is quite a long time ago now, feels like. Yeah, there you go. Zero errors. Yeah, I'm going to see some C++. I'm learning some threading with C++. Which is it. I've been less diligent with it recently, so I can't say I've been that good. But yeah, it's always good to go back and study, and I try to take notes when I can, when it's relevant. I got a little, not burnt out, I don't know what the right word is, but it's like... I don't know, where you kind of get bummed out for some reason, and you just kind of don't want to do stuff anymore. That's been... I'm feeling a lot better now, but... that's what I was feeling for a minute. That's why I haven't been working super hard outside of stream. Now, can you do this? Am I just... No, I don't think you can you? Sag. I think this will work. Yeah. Render 2D. So I'm going to rename these, unfortunately. This is kind of awkward. Render 2D will be what it's called instead. In fact, one of the things that like cheered me up yesterday was coding the audio. That was actually really fun. That was one of my favorite. That was a really fun task that we did yesterday. Now I want to rename. Can I do this? I hope. Well, I mean, it doesn't really matter, but yeah, it was really fun yesterday. yeah, puzzling out the API that we're going to use, and then figuring out a way to decouple the the audio from the entities, which made it really nice. So it was really independent. That was really fun yesterday. Got a bit carried away, admittedly. 2D rendering pipeline. Yeah. I want to write my own scheduler. That's the plan anyway. Oh dear, oh dear. Let me just plug in the laptop. It's just about to die. I mean, threading, I like the way Casey talked about it in his videos. If you do, what I'm going to go over as well, I'm reading the C++ concurrency book, Concurrency with C++, which uses C++ 17, so it's actually kind of old, but for threading it's fine, as long as you're in more or less in the future, doesn't matter that much. And the Casey Moritori's Handmade Hero, and he talked about how threading isn't in itself that complicated. It just adds an extra layer of complexity on top of everything. But I hope to write a half decent scheduling algorithm inspired by Handmade Heroes code and the stuff that I find in Concurrency with C++. So that's my plan, which I'm working on off stream. We'll see how it goes in the end. All exciting stuff, all to make me better as an engineer and all that kind of good stuff that we all love. Okay. Now I've got to decide what to put in here. Oops. If not defined. There we go. Okay. I've completely thrown off the IntelliSense there by using the wrong thing. I used define twice. Okay. So we're gonna have to have some state in here for sure. So I don't know how. There's gonna be a giga struct for now. You're going to put up with a bit of a big blob of data, which is chill on my end, but you may dislike the. So we effectively want this in the initialization code. And again, I make this into a single. I don't know what this object's code is going to be like for now. So, oops, what am I doing? Is this defined out or something? Right, we'll see. We'll see. I think IntelliSense is telling me it's grayed out for just because I messed it up earlier. Render 2D int it like this. I'm gonna throw that in there. Oh, bruh. There we go. Go here. Alright, let's comment this out because I feel like IntelliSense. I've completely blown up IntelliSense. If not defined, define. Oops, have I got this wrong way around? I think I have. I literally typed this all backwards. I think. Yeah, okay. I don't know what I was thinking. I obviously was yapping too much there. Right, okay, so we need the file loader. We need a graphics pipeline creation code. Some of these are variables, so yeah, let's grab everything where we need. Not as of yet. To answer the cap. No, I don't have any implementation ideas. A lot of my threading is very weak. It's actually the reason I decided to go on this bit of Odyssey off stream is because my threading was like one of the weakest parts of my own programming is like I don't really know threading that well at all. So I was like, you know what? Let's build a little scheduler, right? I'm probably gonna try with the basic job-based threading algorithm. The basic, you know, a job-based threading algorithm that kind of does that. So maybe I'm talking too much at the moment, but I have started the research to do this. I just need to keep practicing and writing threading code, which I'm doing. Like I said, I'm doing that off stream. It's not, I think it's that entertaining. So once the stream is over, I basically will go off and do threading studying. Okay, so what else do we need? We need the inputs, audio, no, keys, inputs. We need file. We probably need numerical limits. I'm probably just going to take that. And we're probably going to need array. We don't need time. Where does this come from? GPU. Yeah, okay, GPU resource. And I think we're also going to need yeah, so we're going to need GPU device, GPU GPU, what is it called? GPU resource, wherever that is. And yeah, that'll do. So yep, we might need these, but I doubt we need them in the header. So oh, hang on, I don't know. We don't need camera for sure. We don't need IMGUI for sure. We don't need time. That just works out the delta. We need file, numeric limits. We don't need to load a GLTF file. We don't need the profiler. We don't need IMGUI. We need the command buffers, and we also need to add the GPU graphics, GPU resource. Yes, in fact, yeah, we don't need to say /graphics here. This is just as it is. All right, so I mean, I'll move these out when I can, but for now we're just going to go with like kind of a lazy approach. Okay, so when we do this, we need the GPU, the same GPU device. Now I'm passing this around as a variable. Let me think about this a bit. You can say CA pushman. So what's this discussion on? The blog is literally what I was talking about. It's not really adding anything to my life. It's literally her problem. Oh, is that to do with AMD and descriptor heaps? I did read a resource about descriptor heaps and all that kind of like physical stuff. It was kind of interesting because it talked about the hardware. Yes, the descriptor heaps are hard. Descriptors are hard, sorry. That was a really good article that I'm not saying that you have to watch the video or read the article, but I did enjoy that. Descriptor heaps are hard in the resource. It was a cheerful ears. So I took a load of notes on that and decided that buffer device addresses are the way for me. In one word, CA pushman. What's CA? Sorry, I didn't quite understand that. You can say CA pushman. What's that mean? Yeah, I don't mind that as long as no one gets upset and anything gets spiky. You know, anyone gets upset. You know. Not heated discussions. Engineers discussing different topics is completely chill. Passionately, because we're all passionate about graphics, as long as no one's being a douche. Now, which I don't think anyone is. So yeah, you're allowed to on the stream, you know, enjoy your time here, and if that involves, you know, talking about that kind of stuff, that's chill, I think. Oh, okay, right. It's your username, CA. Sure. Okay, yeah, I'll call you CA. Yeah, it's a bit of a tricky one when I've got pretty bad dyslexia, and it's like, oh, I've got to read people's names, and people come up with the maddest usernames, and I'm like, ah. Yeah, reading is not. No matter how hard I try, it's never gonna get easy. But yeah, that just makes me want to try harder at coding. So. Yeah, as long as people are being considerate about their heated discussions, then I'm happy. But yeah, it's as soon as someone starts insulting this or that or anything like that, then we will have to I will have to kibosh the discussion. But I don't think that's happened. That's only ever happened once in our stream. And they're gone now, so yeah, we are all good in the hood. Anyway, so we have a graphics pipeline that gets created. We have 2 shaders. Very nice, very nice. Yeah, so yeah, people might have to excuse me of my terrible reading skills. You know, I was calling Detricode code for a long time for some reason. You know, it's not just you. It's literally everyone. Do not mention the incident escape point. Yeah, that's true. I should. Yeah, I should be careful. We don't want to accrue any more of that. It's like talking about the devil. Yeah, if you talk about the devil, he'll arrive or something like that. It's some kind of thing. Anyway. So what is the buffer that we want to create for our particular thingy? Into it, so we initialize the graphics pipe. What do we want to do next? That is the next thing. So we want to obviously have a buffer of memory. But here's the thing, right? Okay, let's go back to our thing that we're going to be inspired from. Our older engine, Tempest, which yes is very It's if you're curious about what this is, like a slightly modified version of the Hazel engine, all the way up to the entity component system. Because even back then, I didn't want an entity component system. So now I need to figure out what goes in this, because this uses vertex buffers and all that kind of stuff, which I don't want to use at all. So first thing we've got to figure out is, what are we passing up as vertex attributes, I think? I think we do want this, right? So this is the first thing we want, but we want to set these to 1. This is going to be 1. We're not going to worry about the... Yeah, so that's the first thing I'm going to take. So when here's an interesting... I just had a thought. Why was I thinking this? I was thinking this is kind of stupid, right? Yeah, we could just make a texture. Okay, so that's the first thing I'm going to do. I just realized the max amount. I don't know what I was thinking. I was thinking something stupid. When it comes to textures, I was like, oh, this is going to be really complicated. It's really not, because all we have to have is a texture. We just have to have the dummy texture, actually. The dummy texture does this. Let me. Okay, I'm going a bit rambly, like I'm a mad person. Okay, so we have a dummy texture here and a dummy sampler in the main Vulkan code, right? Here, right? And this actually has the white texture in it. So in fact, we already have the texture. This is for example, let's just say you have a GLTF model with no textures, roughness, albedo, all that, right? You just have regular textures. What I do is I replace all the textures with a dummy texture, and that dummy texture is literally just a single pixel of white. That's what this is. So yeah, we don't have to worry about the textures. It's already in the bindless descriptor set anyway, so this is actually going to be a lot simpler. The longer you write Vulkan code, the more insane you get. Yeah. What will end up happening in the future then? That's funny. That I just imagine myself, right? 2 years from now, like I'm incoherently talking gibberish while I have like gibberish on the screen. My Vulkan code is extremely incoherent. You know, I optimize a loading code of something like that. Yeah, you're not wrong there. It does make you a bit insane. Okay, so we already have a dummy texture. We already have that white texture, which is nice. Now we need to set up the model data, which is going to be extremely simple. And I don't think I want it like this. Let me think about how I want to do this. So, I think it's going to be simpler. So they're the vertex positions, and when I do a buffer device address, I also need to send up the texture coordinates. I think what I'm going to do is have texture coordinates and position just kind of hard-coded in as a value. I'm doing everything I said I wouldn't do, actually, which is kind of funny. What I mean by that is I said I would hard-code this into the shader, and I'm kind of already trying to figure out how to make this into a buffer device address so it actually gets uploaded properly. Huh, I didn't know you could do that. Can you do that in the other Visual Studio? No. Okay, weird. Like, I could be explaining my texture loading system and they'd lock. Yeah, lock me up for being crazy. Yeah, I had a feeling like that. Your custom, you've accidentally made a custom texture loading format, which is kind of, it's really sick. But I'm also a bit, it's kind of funny because I was like, yeah, this is like really cool, but I don't quite understand what you're saying. Yeah, so it's kind of like that, you know. Maybe one day I'll be as insane as you with that. Because my texture loading code is extremely basic. It just loads everything as RGB8 unorm. And obviously you have a lot more going on with your I think you use a G buffer, right? So I think you have to worry about, which I'm going to use, but so I will probably get as insane as you at some point, Ratchet, with that. Anyway. Right, okay, so we have the dummy texture. We need to have a hard-coded thing here, kind of like a... let me think about this. So we want a plain old data struct, vertex attributes, and we want to have a uint float. Oh no, how do I do? Yeah, it's uint 16. Okay, so x, y, z. I'll do what it. P W. And we want uint 16 t for texture u and texture v. Now, this is going to be this is the thing that's going to become a buffer device address. So we need to create a buffer of data. What I'm going to do is, for simplicity, is make an array. So we have vertices. So then we do kind of like, no, that's not how my arrays work at all. I've been coding too much C++ stuff. Alright, let me fix the looping music while it's refreshing. I will vertices dot intit. We need the system allocator. I think that's pretty accessible for us. So memory service instance and do this, and then our system allocator. No. This is a scratch allocator, 100%. Now we know how big this is going to be. This is going to be, I think it's going to be 4 elements. And I'm just going to make a simple, let's put this in a namespace. So it's static, an anonymous namespace. And we're going to put a static const expr uint32 I don't know, size s size of vertices, like total vertices, I say total vertices. All right, and this is going to be 4, so we're going to have 4 vertices, so 4%, no. Yes, 4 vertices and 6 indices. That's the actual key per thingy. So that's quite interesting. Total number of. So let's restart the music. Whoa. I don't know why I copied and pasted that. Okay, cool. We shall go loop next. Hell yeah, brother. Oh yeah, nice. I like the sound a lot. Okay. So this is going to be pretty straightforward, but I've got to be careful here. So each vertex is going to be following this. So plus the texture coordinates. So it's going to be quite tricky to write correctly. So these are the nope. There's no way to. That's what I want to do. And so they're the positions. Pos and texture coordinates are. Let's grab them, which are quite straightforward. They're also here. So these are the texture coordinates. Texture coordinates. So text. So these just need to be in sequence with each other, so they end up going in a nice buffer device address that we can upload to the GPU. Oh, we need the do we need to quantize these guys? I think we do with the let's say load gltf. We have a function here that quantizes things from, I know it doesn't matter that much, but might as well just be consistent. Where's my loading? So what I'm looking for is the quantize half, yes. So this is pair, and this comes from the mesh optimizer library. So I need to be able to make sure this works as well. So actually I don't think it knows what this is yet. But we can grab that in from our includes. The mesh optimizer.h, which is pretty big, but for a very simple function. If I wrote this function, it would probably be wrong, so this just takes in a float. Yep. It almost doesn't matter at all, this, but let's stay consistent, right? Now just a quick question for my own self. When I'm loading this in, right? These values are, yeah, the uint16, cool. 2D renderer. Let's go back and let's build this motherfucker. Okay. Vertices dot push. No, we want to access them with the operator. 0 equals. Okay, so just make sure this is correct. So we have a. Yes. Okay, so we can use C++ 20 features here to make our lives a lot easier. So we want to do dot px equals minus 0.5f. This is why I'm using C++ over C, by the way. Oh no, this is C. What am I talking? Literally, I'm saying, oh, this is a C. Oh my goodness, I just mildly embarrassed myself there. This has been in C forever. Right, okay, never mind. But there is a reason why I'm like, convenience features like this are, so this needs to be 1, is the difference. And PW, this could be anything, so this is the pad. Yes, padding. I should call this pad actually, just so we know we're not using it. Pad. Okay, so tu dot tu, sorry, equals 0.f. Oh, with our function, which I can't imagine quantize result needs to be. Okay, let's just have a quick look. If it's 0, does this do anything interesting at all? So it takes this. I have a feeling that 0f is the same as 0. Yeah, let's see if we can get around this, right? So every time we use 0f, I have a feeling that we don't need this at all. Considering the texture coordinates are 1 and 0, I have a feeling that we don't need this because, okay, this is a bit of a risk. I assume that halves in, because we don't have halves, right? The half component stored in 16-bit numbers, when it's 0 and 1, are both also 0 and 1. I'm going to go off that assumption. I'm going to write myself a comment. And we'll see if it works based on it not completely self-destructing. So we are assuming that the values of 0.1.f and 0.f are both 0 and 1 and 0 respectively for halves that we are storing in uint16 underscore te. Right, cool. Now we just need to duplicate this. Okay, so 1, 2, 2. And now we just need to add our lovely values in. So this is that, cool. Minus, minus, plus, plus. 1, 1, 1, 1. Yep. And the padding is 0. We don't care about that. So now we have 1, 1, 1, 1. Okay. Next is to not forget to do this, because that would be a mistake that I would not see. Okay. Now we need to create a buffer with this. So yes, the IEEE 754 floating point number uses binary 0 to represent 0. Thank you. In any precision, single, double, half. Thank you, thank you, thank you. I appreciate that. Yeah, so that just simplifies my code then. I don't have to worry about converting between the two and all that kind of stuff. While also compressing the data that gets passed over to the GPU. Right, perfect. Next is to create a buffer, which I'm just going to snag from my code. Oh, is the music stopped? Yes, we are still listening. Okay. Let me think. What am I doing? I'm higher up. So when we create a buffer, this is important. We need a buffer handle, yes. And we need to make that buffer the right size, which is fine. And by the way, this although it's a pointer, when the buffer is contiguous and there's no like offsetting you have to do, and you're mem copying the whole thing over in one go, this particular type of buffer works completely fine. When this doesn't work with having to increment. So if people look at that and go, you're passing a pointer there, there is like a reason behind that madness. Buffer creation, buffer, and you know, people might say, oh, have you proven that to be true? Well, if it wasn't true, then none of my code would work at all, because that's what I've been doing ever since the beginning. So anyway, so no, that's wrong. We need to set the size here to be this, and then the vertices dot size, right? Multiplied by that. That's important. We get that right. So now we want the vertices dot data. Nope. I'll just type that in. And now we need a buffer handle. Now I assume we are going to have more than just this, so what do we call this? We call this vertice vertices? B. I don't want to call it vertex buffer device address. How about that? Vertex, because that's what it is. Buffer device address handle. Very nice. And we're going to do the usual uint32 max. Obviously, we don't want that to be true. This is in, where's this? Oh, never mind. I forgot we're doing a buffer handle, not an index directly. So a buffer handle is just a struct around an index. I forgot. Okay, so, but literally vertex. Almost forgot what I was doing. Okay, so now we have a buffer. I think that's as far as we can go in this initialization function. We have depth on, which I don't know what we'll do about that. We have the shaders, we have the pipeline. We create the pipeline, which is automatically creates the same push constants, so we don't have to worry about that. We create all the data that's necessary for a rectangle, plus texture coordinates. And then we create the buffer device address handle with a bindless texture with so we can actually access that. So now we have the buffer device pointer that we can actually use. Nice. Okay. By the way, escape point 0.h is not the same as. It isn't. Okay, that's what I wasn't sure about. Okay, thank you for that. Thank you for catching that, by the way. That's really nice. Nice of you to notice. I wasn't sure, so let's bring that back in. I will believe Ratchet on this one because I'm not sure myself. So Ratchet has pointed out that I'll explain, just for the other people. He has spotted that I've set my texture coordinates. No, not here. Where is it? I'm looking for a. Right now, I'm just looking for this include. So I'll explain that when we get there, actually, rather than talking about it now. So let's go back to our 2D renderer. 2D render. Do I want to call it that? Anyway. Okay, so here, right, these are my texture coordinates, U and V. Now, I've assumed that the same binary representation of float is the same as a half, which isn't true. Okay, so I can't just call this a 1. Right, okay, so quantize half. So what this function does is it takes a 0.f, which is what this needs to be, and it converts it to a half and stores it in 16-bit format for us. It does make our struct a little scruffy, but nothing a bit of this doesn't helps with. So we can't assume apparently that 1f, and so a float is 32 bits, a half is 16, and we're doing that to save space when we're passing stuff up to the GPU, and it's trivial on the GPU to turn this back into a regular float. So right, we have a buffer, we have a buffer device address now. What else do we need? We need the position buffer device address, which is actually where things get a little tricky. So we need the next buffer device address to be created. Let's just check our shaders one more time. So that's our vertices. We need the color plus position, and then we need these three buffers. This one should have been created on in the main function, so we're not going to do that, but we do need the other one. We do need the positional data, because that's going to be done per instance. So for every single time that we call a draw quad, right, void draw quad at something in a minute, I'll get to that in a sec, we need to be creating a buffer. The problem is with my old renderer, this was all done in draw time. So I would so let's just see how let's just see how this idea works. Right, so in my old renderer we had this idea of a struct. So this is the second buffer. This takes the position and the color. Let me think. So this takes the quad position data, right? This has 3 components. It has the matrix 4 position, and it has a vec4 color. Yes, I spell it the English way. We have the vec4 position, and then we need the pad. So float pad. I always put double D for pad just because I wouldn't ever type that out if I actually needed that variable. Okay, so we also need to keep track of other things. We need to keep track of the total number of... Let me just type this out in the comments. Actually, I'll do a C-style comment. So, we need to track instances. So the total number of instances. We need to track the index is. The indices, which is plus 6x the number of instances. That's not how you spell instances, but we're rolling with it. In my old code, I spent color in the same way, and then color in some other character. That did cause me problems. Well, yes, it's always caused me problems when I'm typing out a Vulkan specific code for like a memory barriers or something. I always type color wrong, like color attach optimal or whatever. I spell it wrong. Okay, so instances, we have indices. How do you spell instances? Let's spell this right. Instances. Right, I'm just gonna Google this because I'm going nuts. Instances. Instance. I want an instance. Instance is right. There we go. That. I was getting mixed up with indices because I'm thinking. Right. Okay. Done. Thank you. So we need instances, which is that, because we're going to do a instance index draw call for this. I don't think we need to do anything more complicated. But we need to do this in a way that's efficient. And obviously we need to track the quad position data, right? So I believe they're the... Let's look at our... okay, so we need color, text code. We don't need text calls. We don't need tiling factor, really. I mean, we could have tiling factor, but we'll not worry about that for now. Texture index. That's going to be our instance variable, I think. Yeah, so this is pretty much it. Let me think. Why is this 4? A loop of 4. Shouldn't this be completely redundant? I mean, it's doing it per vertex, right? But if we've got all the vertices pushed up to the GPU in one go, then we just multiply the position by... we do this in the shader. Like, I don't know why this is done on the GPU. And that's the index count added, and that's the instance count. Instance count and... I mean, we actually don't need to store the instance count, really. What should flush reset do? So this is... max indices. Okay, so... if this exceeds, then we do a... Right, I see. So what this is doing here is we're moving on to another 20,000 elements. For now, I'm not going to worry about that. That's going to be something we can test later. If you remember querying uniform locations, you'll get it. Ah, right. Yes, I do. Okay, yes, that I can imagine that been causing issues. Oh man, that brings me back. This was the last OpenGL engine I ever made. Ever since I kind of dropped it. I don't know when I started with Vulkan, but it's been a couple of years now. Anyway, so the idea is we have draw quad used in different places of the renderer. And this builds up a static object that contains all the data, which is fine. And then later, let's just see how this actually presents the data to the screen. How do we pass this up? Okay. This is really quiet to me. Let's turn this up. Now, I'll turn it down for the next song, but... yeah. OpenGL, the GOAT. The forgotten GOAT of our time. I mean, I never disliked OpenGL because I never really got that good at graphics, honestly. with this. So I just thought OpenGL was... I honestly thought OpenGL was sick at the time, to be honest. Right, okay, so this is all well and good, this particular code, but when we actually get to the point where we need to actually send all this to the GPU, which is done here, looks like with uniform... What are they called? Uniform location thingies. What does actually get sent? Because I'm kind of curious. I want to see... Obviously, you want to do this one draw call. And if I'm creating a bunch of stuff at runtime... I don't have to create it at runtime, to be honest, but... Anyway, let's see how this is actually done. I want to see... Because the initialization. Right. How are you used though? Okay, so we don't want render 2D. We discovered there's nothing in here. Oh, really? Oh, let me guess. It gets returned out as a variable or something. I used to do all sorts of stuff. Ugh, this is gonna be annoying to find. So when we actually want to render this, what do we do? NC? Is this it? Looks more like it. What does flush do? Ah, there it is. Okay, so that's what I was looking for, like the index draw call. Yeah, I'm glad you recognize this, JTag Dev. Yeah, this is very hazily. I will not deny that 100%. I'm still a bit of a noob nowadays. I'm not going to deny that, but when I was even more of a noob, this is what I was using. There's this one guy that tried to argue that OpenGL 1.1 was the best API ever, and everything else was useless. Well, that's the thing about opinions. Everyone's got one. They're not always good. There we go. Yeah, I'm glad someone else followed these tutorials. That's sick. Yeah, they were fantastic. I don't know where they're up to now. I stopped at the entity component system. So I don't know how many episodes that was in. 50-ish. Oh, he's kind of... Oh. Really? Oh, that's actually sad, dude. I stopped before he quit working on it? Oh, that sucks. Oh, never mind. Now we got sad music playing at the same time. How appropriate. Anyway, so let's see this code. Like, what is actually... Ugh. Okay, so the OpenGL code is doing what? Ugh, my goodness. Not a fan of this multiple... I mean, I have too many layers of indirection, but geez, I didn't realize there was this bad in here as well. I do not remember this function at all. Right, okay, so I think what we need to do is just have a present / update function at the end that takes all our draw calls, and then we can do something with it, right? The downside of that, though, is if we do it at runtime, which would be useful, is it appropriate to make a buffer at runtime in the actual loop every single frame? That seems slow as hell. I'll call it quads, never mind. Let me turn the music down again. Now we're on an actual reasonably volume. Yeah, it is sad, yeah, but at the same time, it's not scalable. It's not a scalable design. So it's kind of best... Oh, okay. Yeah, I never followed it beyond like a particular point, so my idea was I'm going to make my own version of Hazel. and call it Tempest. I barely was able to get past anything, honestly. So yeah, that's kind of sad. This was in like, I can't even remember, 2018, 2019. I wonder why it wasn't scalable. I have so many questions now, but I don't want to get too distracted. Feel free to fill me in on the Hazel lore. I'm totally fine on being filled in. I'll have to read what you want to if you want to talk about it rather than ask questions. Otherwise, I'll get completely distracted. Because that is news to me. All this. Because I haven't been on the Cherno's YouTube channel in a while. Not about any issue with him. I don't have any issue with him at all. Like, I don't know. I just haven't watched him in a while. That's all. Oh, Tempest is such a good name for an engine. Yeah, it's sick, isn't it? I came up with it with because I had Wind, Cyclone. What was the other one? Air and Tempest. Tempest is probably the best name I've come up with. Void is just the absence of air because I couldn't think of anything. It's almost like a stand-in name. Anyway, so yes, I think there are still some of the community contributors working on the big, Hazel from his Patreon. Oh, okay. I mean all of it. Lol. Static. All of it. Lol. Static. Every single service. Not that static is bad, but the static singleton for everything. The layer stack. Not a bad design, but better suited for UI frameworks. Singletons are really global state. Okay, so which ultimately is why Hazel is more of a GUI application framework than a game engine. Interesting. Right, okay. Yeah, because I tried in other engines to implement layering. Now you've said that, and it was such a pain in the ass to even get remotely anywhere with it. It was so awkward. It's not that I came up with a better design, by the way. Like my engine after this was what was after Tempest? I think it was Gust. I forgot about the Gust engine. And it's just a Vulkan renderer. It's just a Vulkan tutorial with a bit of extra stuff going on. And yeah, I just could not get the layering to work, and that was his big thing right at the beginning, just to add layering. And he said that this is what the major game engines do. Right. Yeah, I've got more global state probably than you guys have, but yeah, I guess I should watch out for that. I do think my architecture is good, but I don't think it's terrible. I mean, the code is like messy, but it's not. I don't think the architecture is bad. I'm trying to go with a data-oriented design approach with pretty much everything. So parallel arrays with indices and all that kind of stuff. Yeah, I don't really like this idea, to be honest. It's tricky because this assumes, I think, this draw quad idea. That let me think about this. Okay, so if I have a rectangle and it gets destroyed, then I would need to create the buffer device address buffer, right? Because now it's smaller. I never thought about this. I mean, Cherno didn't work on the Frostbite engine, really, so he doesn't really know. Oh, okay. I didn't know that. Yeah, I understand this. I have all respect for him as well. I think all of us do. None of us are like, you know, those insufferable types of like, he's actually really bad at programming. Yeah, none of us are like that. We're talking from an engineering perspective of why Hazel wasn't scalable, which is, I totally get it. No shade, no shade. I wish I had a cool name for my renderer. Yeah, I don't know. Unfortunately, my engine is named after someone else's engine as well. I didn't realize until like a month ago that a game studio has also got a Void game engine. So we'll see how long my game engine is called Void. He's not that bad at programming, but he only worked on the NSF mobile and didn't really see any real internal engine stuff. Yeah, I know he worked on the mobile, but I didn't realize that. Interesting. Okay. There we go. The more you know. I know he's had criticism before, but I know you're not criticizing him to bring him down or anything. But yeah, that's new to me, all this. I haven't kept up with the channel at all. Yeah, like you said, all respect all around. We're still on random? Sounds good. Anyway, okay. I've got to be careful with this now. Because I've just thought of something, right? Let me yap for a bit about the actual engine. Now, let's just say I have a instance that I'm rendering, right? And I want to delete that instance from the renderer. How do I do that? Because I hadn't thought about this, right? So, obviously when you kill an enemy, you know, in any video game, or collect something, like, it needs to disappear from the world. Now, if I have a buffer device address that we just index into based on an instance, how does that work, right? Oh, Need for Speed Mobile. Thank you. I didn't know what NSF was meant. Thank you. So the problem is right now is I'm in a position where I might have to do something a bit different than what I'm doing. In general, not just for this renderer. Let me change this to quad rather than quat. Because I have a ways to... I don't really have a ways to add and remove things from the renderer, I don't think. Which is kind of interesting. So why don't you have quads per UI element, by the way? Don't you need to just pass the difference transform? Let me answer the United States of America. Thank you. Didn't realize I was attracting the whole country. Okay, so why use Vulkan if you could use something like OpenGL? Because it's not like the performance is a huge factor as the game is 2D. Sorry, I'm writing a 2D renderer, but the game is 3D. Let's see if this runs right. Let's see. Which is fine. Great question, by the way. There's no let me. So there we go. Like this stock will eventually be a spaceship. We'll be flying around space. Yada yada yada. Why use Vulkan? There is a very simple 2 reasons. 1, I want to, and 2, it's cross-platform. The reason I want to use Vulkan is because I want this engine to be supported in the future, long into the future, like 20, 30 years, right? And with newer hardware advancements, I want to stick with the newest. I want to stick with the newest APIs and all that kind of stuff, and keep up to date with things. So I'm moving with Vulkan, and eventually, when Vulkan 2, whatever that's going to be called, like I don't know, OpenGL Vulkan, GL Vulkan, I don't know, whatever it's called, I'll move to that as well. So. And this also runs on Linux, so that, yeah, those are the general 2 reasons. Yeah, oh, thank you, thanks for the compliment, the United States. I'm just a small kid trying to learn to code. I'm 10, so please don't bully me. Cool, that's all I have to say about that. Just make sure you're, to be polite, I'll say just make sure your parents know what you're watching. I don't think, I don't have any rules or that. I don't know if you can have a YouTube account if you're 10 years old, but that's neither here nor there. Yes, you can totally learn to code at any age, by the way. Feel free to be chill. Although yes, you can't, yeah, just, yeah, I'm not going to bully you or anything. Don't worry about that. Right, okay, so here's my problem, right? I think you're right, by the way, Ratchet. No, it's a Google account restricted by my school. Okay, fair enough. No problem. Yes, that's fine, I guess. I have younger brothers and sisters. Anyway, so here's something I've just thought about with this whole architecture, which may derail my whole 2D rendering plans for now. Okay, so let's just pretend we're flying around, and I delete this rock, right? I crash into it, it blows up, and I want to remove it from the scene. The instance count needs to be reduced by 1. So the duck is always moving, I can't stop that. How do I how can I, let me think about this. I need to be careful now, because because eventually I do want to remove stuff from the scene. If I got a buffer device address uploaded to the GPU, and I want to modify what's in it by removing an entry and reducing the instance at an arbitrary point in that, how do I do that? That's the question. Because I've created all my buffers before we render. And it might be the case that I need to have a queue or something like where we decide that we need to, based on a deletion thing happening, we need to recreate the buffers that are tied to that particular entity, which in this case would be the debug geometry and the positional data. Oh hi, XWO. It's brilliant to see you again, dude. Thank you for joining us. Windows still has support. It does run on Linux, so that is a thing. Okay, so hi there. Hide it at first, then later remove it. OCE. Oh, sorry. Then remove it once you are out of the render pipeline. So yeah, I need to. Okay, so XW. Oh, he's actually really good at programming, so I'm going to ask him a question directly. You don't have to answer. Your job here is to chill and have a good time. But I will ask you this. Does that mean I need to create... If I'm using buffer device addresser, does that mean I need to recreate the buffer device address from scratch if I've deleted one element from it? So let's just say I have 1,000 rocks in the scene, and I remove the rock 777 from the list. Do I then need to recreate that buffer and pass that up to the GPU for instance rendering? That's the question I have. If anyone has the answers, feel free to answer. How did you take time to set up Vulkan? I only have ever used OpenGL make a voxel engine. Nice. And made a small God of War game, but nothing on this scale. Did you use a template? No, I just made multiple engines. They were all kind of bad. And I just got better and better. How I set this up, I used a book which I kind of regret using. For a small few reasons. It's called Mastering Graphics Programming with Vulkan. Yes, you could use Vulkan on Linux as well, but not Mac. Yeah. No, you just re-upload the data, the new data. Re-upload the new data. So I just have to make the... Okay. Let me think about this for a bit. Because I think what I'm going to do is I'm going to set up a key press that deletes something from the scene. I need to check this, right? Cool. Okay. JTAG is right. Okay, thank you guys. That's very, very much appreciated. As long as the new data does not overflow the initial size of the buffer, then you can upload the new data to the buffer and override the old. Oh, okay, right. Okay, thank you guys. That's actually really helpful. Okay, so let's take a side tangent because this is important. If I don't get this working, then we can't remove anything from the scene, and I just realized that's kind of a big deal. So, because we have, should I have the collision? No, I'm just gonna make it simple. I was gonna say like, oh, when we collide into something, we're gonna delete it, but that's not appropriate. Thank you guys, thank you. So let's try and delete something from the scene with a, I don't know. What do I want to press here? 0? Like that. Okay, so when we delete something, we need to make sure that we hide it first and then upload it later with a smaller... So you don't need to create a new buffer, as far as I can tell. We just reduced... I assume we reduced the instance size. We don't try to instance render into something that doesn't exist and have a out-of-bounds read, because the instance variable is too large now. So we reduce the instance variable, and we just remove that from the scene. So how do we remove something? That's my fault. I need to figure that out. My fault. My problem. Is your buffer created with? Yeah, we gotta make sure. I think it is. Yeah. Let me. It's host visible. The cleanest way for swap and pop is to copy. Yeah, okay, so we copy it to the end and then we delete it, right? Yeah, I think I've got that. Okay, so the cleanest for swap and pop is to copy the last slot into... Let me just read this properly. Copy the last slot into the deleted slot. So we move it to the end and then delete the end, right? Is that what you're saying? Yeah, okay, cool. Fully legal, no overlapping. The one thing that escaped my knowledge is what is a buffer. By the way, I don't mean to be arrogant. Ignorant, yes. So a buffer is just an arbitrary piece of memory. That's all it is. So that could be position and color, for example. You can have that in a buffer where it goes position, color, position, color, position, color, position, color in a big line. That is, it could be literally anything. So when I say buffer, that is like literally anything that we have. Cool. So let's do a delete swap. VK copy region. Right. Yeah. Okay. So the first thing we need to check is this host visible, because if we delete it on the host and it's not host visible, then you know. And we also need to do a delete swap, which is very, very true. I do have a delete swap function I've written for my arrays, so that's great. So we're gonna have a delete swapper, and I'm gonna break everything by not handling uploading it, and just see what happens, right? So entity 88. What have we got here? So delete swap and index, we're going to delete 88. So that should delete something from our entity list. And if it's host visible, I don't know what's going to happen. So it's possible. If right, let me just check. I might be able to just get away with this, but we'll see. We have indexed. So this is the important guy, because this is the instance count. That's the actual important thing. Where is this actually called in our here count of? Oh, okay. So we can just reduce this by one. What model type? Let me think about what's going on here. So we have a. I think this can only be 1 or 0 based on an index value. So yeah, this draws all the. As far as I can tell, this goes into my models and draws all the models that are of the same type. So this is for the instance rendering. This takes the draw call size, because there could be more than like different type of draw calls, right? On a different model for different materials, right? So we have different materials. All our models have one material type, so that's fine. So this is always 1. Okay, so when we go in here, this is the model we're on. We index into that model. Count of model type. So as far as I can tell, if we've deleted something, we need to remove one element from this. The problem is this is pretty specific knowledge of an array. Okay, so let's figure this out. And this also needs to happen for the debug list as well. Yes, so the debug also needs the same thing, because we need to remove, obviously we don't have these variables, so we'll try and get them from the entity itself. Let's see if we've got it. So entities, so we'll obviously we won't delete 88 before we do this, so yes. Okay, so we have model index, which is what we need. Oh, okay. So let's put this in a variable. Model index for now. It's in its own scope, so I don't think I'll clash these. And then we take this, we -1 from these guys. As far as I can tell, this is what we need to do for these. Oh, now we'll see if this works, right? I'm doing this on purpose without any safeguards, right? So just to see it fall apart and what breaks to really get this. Okay, I'll read the. Okay, so that breaks my array. Interesting. What's the size? The index. Oh. Where is that? Okay, so this is here. Oh, and this needs to be reduced, I guess. Which is fine. Yeah, I will look at... Thank you for all the help, guys. This is actually really, really nice of you. I just want to break it, and then we'll do this updating our buffers, right? After we've deleted something from the scene. But first thing, I need to delete things from the... okay, so nothing changed, but I have no idea. Okay, so I'm going to delete the... No. We're not going to find out what that was. But if we delete number 1... Number 1 is... So that's just a random rock. Which may or may not have been deleted, but... One of these is I'm moving this guy. I think this is number 1. So... Oh, okay. Okay, I've gone past it. Let me do a big loop. And we have index 1. Okay, so yeah, this is not working, but this is good. This is what I want to debug, right? Interesting. Entity 1 should be our first. As far as let me so in a nutshell, vk command copy command instance buffer region. Right, I see. So we just do okay. Thank you for that. Actually, that's really, really helpful. So we set up a memory barrier and we do a copy buffer. Thank you. Okay, I've done that before. Thank you. We will do that. As soon as I've stopped crashing with my arrays, that'll be the next thing we do. Okay. Yes, everyone's correct. That assessment of what RAM is. Thank you for helping other people in the chat with questions. By the way, it alleviates me to think about other things. Big W's in chat, honestly. Okay, so we need to figure out why what is getting deleted, and then we can figure out why it's not getting deleted properly. Obviously, there's some kind of arrayness happening here. Well, we should be doing this at a different time, but that's fine. That's But let's figure out what we're deleting. So if we go into scene and our first element should be this. So as far as I can tell, our entity index value is that's dynamic. So what I want to check is, yeah, these should be the same. These should be incrementing by 1. These also should have values that make sense to them. But we'll go through with our breakpoint here. We'll go in there and we'll investigate this. So this might be a try again tomorrow type thing. We'll see. Well, yeah, going back to the 2D rendering. That's what I meant to say. Because this is a bigger deal for me. Because I just realized like how much stuff depends on me being able to delete things from the scene. Why are you being awkward? IntelliSense, what are you doing? Oh, the debugger. Okay. Oh. No? You're not gonna light up these variables? Okay, that's really annoying. Let's start again. I don't know what the debugger was doing then. Not helping. Okay, cool. This is... Let's check. Yeah, okay, so now it's actually doing what I want. So color, shape, this, whatever. Current debug index is 1. Debug render index, yes. Sorry, wrong things. Current last index. Model index is 1. Debug. Oh, am I getting the wrong index or something? That might be it. Why we're crashing in our arrays? We're just basically having a. Oh yeah, that makes sense. Okay, so. Debug index. So we have 2 different indices that index into 2 different model buffers, like oops, like this. Yeah, so these aren't the same variables, so that'll fix it. So that'll fix us accessing an invalid array, and we should see a sphere that goes in front of us. Oh, we don't need this anymore. Okay, so if we press, I had my finger on 0. Whoa. Okay, so that means we've got some. I think we've got an over. An out of bounds read, maybe. I don't know why that's caused that to happen. But at least we know which entity we're trying to delete, right? Obviously, that was wrong. Right. Okay. Back to this music again. This music's sick. This music's sick. This is my favorite song. But you know, I have been listening to this is half an hour long. I won't need to listen to this. I will show you something else that I've been super enjoying recently. But that is my favorite video game soundtrack of all time. Like these tracks, I'll put it on sequence at the moment. Oh, just listen to this. Bruh, that is. I've never played this game. Holy, this song is good. We'll go through the 3 songs I really like, and I will not put you through Streets of Rage, Back to the Industry for half an hour, because that's my favorite song. Anyway, okay, so now we need to do something different, right? So we've deleted it from the array with a delete swap, which is fine. The problem is, yeah. No, it's good. It's good. Thank you for. Actually, I might remove it. I might put because I have 3 different versions of that track. So what I might do is for your viewing pleasure and other people's, it's relevant, right? I might make it easier. It's because it's part of this stream is to like make it enjoyable for you guys as well as for me to enjoy the music. So yeah, it's thank you. It's actually useful feedback. Oh, I'm glad you agree. XWA. So let's continue, right? So we deleted something from an array. It went all silly billies. I might for now, just because we're doing something a bit different, update. I might just use the free camera rather than the player camera. So I don't know what the player is gonna do, but I need to have a different camera, I think, for this. Yeah. So I'm gonna ignore the player for now. That's just gonna do its own thing. So yeah, the player's going off in the distance. Bye. So I'm gonna press 0. It changes into whoa. Okay, I think I pressed reset. My bad. And we have 2 ducks. Yeah, everything's just gone wrong. I think we have a buffer. I don't know why it's not telling us that we've got a buffer over. Right. Okay. So let's do what we're supposed to. Right. So we need to write. What I need to do is if we've deleted something, then we need to do a copy. Oh, it's not going to continue. That's awkward. We'll just click on it for now. So what we need to do is when we do a delete, we need to tell Vulkan to copy memory to the GPU. I think. Or we are already. Let me just check what the buffer is that we're deleting. So we're deleting off. This array. So these are just arrays. But I think the buffer itself. Let me look at the buffer creation code. When we create this, I don't think it's tied to anything. So we have, yeah, host create access. Okay, so I think what this is telling me is we don't have random access. We don't have random access to this array, so we can't just randomly delete something in the middle. We can only write to it. This is what the VMA allocator does anyway. It's request possible map. Yeah, I've messed this up in the past plenty of times, but I think we're restricted to only writing things in a big sequence block. So when we copy the buffer, let me grab my copy buffer code and see if we can. So this is kind of what we need to be doing here, but not with an image. Sorry, where's the copy? Okay, so unfortunately, if we're going to use a copy command, we're going to have to transfer the memory to. Unless people jump up and down and say no, idiot. We need to transfer the memory from whatever it's in. I don't know if it's read. I think it's probably in shader read optimal. We need to transfer it back to transfer, and then we need to do a copy, and then we need to move it back again. As far as I can tell, that's what we need to do. If you update the instance buffer while... Yeah, if you unsense the instance buffer while n-1 is drawing from it, you'll corrupt it. That makes sense. Let's move on to the next song, and then I'll have to put it on random again. That is just telling VMA to create the buffer resource as host visible memory. Yes, I think there's another one though that means you can randomly access it, which is different. So that particular, I'll show you it because I've made this mistake loads. This and this are different. This means you can like read, write, and access parts of the buffer at random. Like random. This means you can only write it in one blob. And you can only write, you can't read. Which in theory is better optimization wise, but that's what I've access host random bit is different from sequential write. Anyway, ring of n instance buffers. Once per frame. Update the only buffer per frame you're recording. I don't do that. Let me I actually don't know. Let me pass through this a bit. Single buffer with an explicit semaphore offense waits before mutation. Okay. You don't need semaphores offense in the same queue. You have a stage. Having one buffer for each frame in flight is too wasteful for huge buffers like instances. Right. No, I did finish the audio system, TT. Thank you for joining us, and thank you everyone for the help. Again, I know I keep saying that, but I do appreciate it. Okay. Right, how do we... Yeah, you're right. We need to... Ugh. Synchronization. We're in synchronization land again. But now we're solving a new problem, TT. We're trying to delete something from the scene without destroying it. So let me chew on this. Ugh. As we try and figure this out. As we vibe to the new music I've been listening to recently. Okay, so this is going to delete it from the array. But if we have one buffer per frame, for all the frames, we need to... Offend semaphore to do the copy. My understanding... okay, so now I'll put it on this and we'll do random. So we don't have to keep clicking on this. My understanding is that if you have a pipeline barrier, you're stopping certain commands from accessing / using a piece of memory that shouldn't be accessed, but allowing other commands to continue. Which means I'm gonna have to talk through this. So forgive me if I'm like not quite there yet. Which means commands that would access that data, I don't know, necessarily the draw commands, I guess, could be paused with a pipeline barrier until that transfer is complete. Meaning that you wouldn't necessarily need to have a new fence / signal to do a VK copy to a buffer and then transfer that buffer back into VK shader read only mode. That's what I'm thinking, right? You can always write a staging buffer and copy it if it's too large. How large are your instance buffers anyway? Are you talking to Jess Lass? Ah, right, of course, because they're all GPU side. I forgot. God damn, this is tough. I guess this is the synchronization again. So you're right. So if we're updating stuff on the CPU via a copy, then the CPU and the GPU need to be synced. Otherwise, yes, we'll be pausing the draw commands, but the CPU and the GPU aren't synced. Now that is true, we probably need to ask the question then, or I need to ask the question. Is it possible to take advantage of the frame? So if I go into here, right, let's scroll down. This is create, resize swap chain. Might just look for it now. Whoops. Present, right? So I actually need new frame. New frame. Okay. Right. Okay. So is it possible to take advantage of the fact that we've waited for a fence here and do the copy here? So we've reset the fence, we acquire the semaphore. Yes, we acquire the image and all that. Like at this point, the CPU and the GPU, I don't know how long they are synchronized for, but can we say, like, I don't know, do copy, right? Assuming that we need to update. Alright. Hello, Nilo. How you doing, dude? Thank you for rejoining us. Yep, the CPU is mapped. You need... Nub... sorry, Yep, the CPU is mapped. You need the CPU is mapped. You need to buffer. Using the CPU mapped for instances is not good. Even when you rebar. That's... Oh, we need to be -1, don't we? We need to be -1 frame if we're going to do this. This is a... Apart from the limited host mapped memory available, any additional data you see as host visible due to rebar goes through the DMA and copy transfers behind the scene via the GPU kernel. Okay. You've caught me out there. I don't exactly know what's rebar mean. I can Google that though. Let's learn on the fly, hey? This is what it's all about. When I said I'm streaming Vulkan and C++ Game Engine development, I didn't say it was the best. What is this? Resizable bar. I see. Okay. But what is it though? Resizable bar, base address register, or rebar for short. Okay. Is a modern PCI Express feature that lets your CPU access the full video memory VRAM. Okay. Of the GPU directly, removing the old 256 MB limitation and potentially reducing the bottleneck in data transfers from the CPU to the GPU in games. Right. Cool. When supported by hardware, the CPU, motherboard, GPU properly enable rebar can improve performance in certain titles. Okay. Let's say so the DMA with rebar. The CPU, okay, so nope, that is what you see in user mode in the Windows kernel. For the GPU, this is how it's implemented. Okay. Rebar is the ability to expose the VRAM to the CPU. I see, okay. Thank you. I think that makes sense, yes. Drop your sources. It's like a standoff. I do not have... hi, Toby. I do not have the sources outside of an NDA. I wrote like that when I implemented our GPU kernel driver. Wow. Damn. You wrote a kernel driver. That's really badass, honestly. Right. Okay. So how do we continue from here? Right. So I need to think. Now I could just write a new fence for a copy. Let's start writing a function, right? And I'll do the most heavyweight. Now everyone's going to try and beat me up after this, after I write this. But what I'm going to do is do no semaphores, no fences. We're just going to do a QA idle at the beginning of this function. So I know that's not the best, but I just want I want to see if we can do a transfer, right? And then I'll do so since we've done a wait QA idle, I'll eventually improve that synchronization with a copy. We'll do a QA idle copy with the new buffer with a copy region, and then we'll transfer that memory back into shader read. Not entirely sure if we're writing and destroying memory, but hopefully that QA idle, obviously it's really slow, will show us, well, show me at least, that we are pausing the frame properly, we're letting the GPU and the CPU synchronize. I believe this is, I believe my notes at least say that QA idle is more heavyweight than fences. If it's host visible, you can just do a mem copy with you outside of the render loop. Really? It's that simple? At 64 kilobytes, a triple buffer, the whole argument is academic. Pick whatever's the simplest. The size, GPU driven, only concerns. It's only a matter at large instance counts. Right, okay, interesting. Thank you. Damn. I've got some real cool guys in the chat, honestly, so I really appreciate this. I'm stealing all your knowledge. Okay, right. Right, okay, let's try the simplest thing. Let's just see if we can do a... the whole point of host visible memory resources that you don't need to do staging buffers. Okay. Okay. I think it's host visible. As far as I can tell, we just need to push everything back up. Okay, so let's... As far as I can tell, that means we need to... What do I need to do then? Just do a mem copy. Just literally do another mem copy. And... entity data. I don't think we've done anything with that. So let's see this. Total entities. Outside the render loop. That's the thing that's getting me at the moment. The render loop is... So this is the handle events. This is... Everything's kind of homogeneous together. It's not great, admittedly. And if your GPU and motherboard do support rebar, then you have access to pretty much all the VRAM and host visible memory. Not all motherboard and GPU support this, sadly, and hopefully the future will see rebar do a de facto standard. Cool. Right, okay, so what are we doing then? Obviously we just want to do a mem copy. These are visible by memory because I do this all the time. I do this every single frame. I do a memory copy to Alex. So this is supposed to be updated every single frame, meaning that, for example, this guy, we need to update the position of all the dynamic geometry in the scene. So we literally just push that to an array, and then we just this is basically a VMA mem copy. Without all the setup and shutdown of the actual setting and unsetting, unmapping and mapping stuff, right? What I do in my engine is I have a small transfer queue and a large transfer queue. My instance goes via the large transfer queue. That does not wait for a frame. Unfortunately, we need a staging buffer with my approach. Cool. Right. Let's think. Outside the render loop, we just need to do a mem copy. of what? The new buffer? Or the same buffer with the same memory? This is the thing I don't quite understand. If I'm just doing a mem copy, right, because it's host visible, yeah, I can just access the buffer again. I don't need to do anything fancy with the let me think. I am learning a lot. This is for those who are watching who are like learning Vulkan, just a bit of a aside. I'm a bit confused at the moment. Just so you're aware, I'm learning at my maximum right now. This is like a cool thing I learned recently about learning. Neuroplasticity feels like confusion. So this is why I'm very grateful that I'm in this position right now, where I'm kind of a bit confused and a bit like, what the heck's going on? Because this is what it feels like to be learning at the fastest rate possible. That's what I've learned anyway. About learning. Did you write everything yourself there? Yes. But what I'm a bit confused about is when we are pushing. What might be happening actually? I might be doing some of the copying, right? So this is copying every single frame, no matter what. But maybe I'm not getting all the buffers, right? Scratch allocator total entities. Like what? Okay, so we don't mess around with this. This is a buffer device address that's just VK VMA copy memory allocation. Programming is all about a lifelong journey of never-ending learning. Love that, dude. Yeah, I appreciate that. And yeah, we can we get better. Yeah, I'll never be finished with this journey. Right. Okay. So let me just check that every single piece of data that I'm dealing with right here is actually going to be. I've got a sneaking suspicion that this... Okay, this might be completely wrong, but let's just see. Okay, yes, we need one less entity. Count of type, though, I'm not entirely sure what we use that for, so... Not every GPU supports rebar. Yes. As I've been told and just learnt. I'll be having to take notes after the stream. So ignore that, that's the player. Oops, press minus. Okay, interestingly we get a duplicate. So that should have been deleted, but it didn't. So yeah, ignore the player. The player's just going crazy. I do use IMGUI, but it's just not turned on at the moment. I don't really need it. Right, let me just see. Oh. Press it. Am I pressing the right button? Yes. Let's check I didn't accidentally delete the other one. There should be a... are these always lit up like that? Okay, that's just the player. Nope. Ah, okay, so... We've got a rock here, and I think the duck's inside this. Yeah. So, clearly, we... I think we are mem copying, but we're not. This is host visible, so it should be able to do what we're doing, but I don't think I'm deleting everything from this from the arrays. The duck hates you, that's why it's going. Yes, I know. It's something to, yes. Oh, that's terrible. Wait, where is the duck? Yeah, it's a stand-in, but I all my videos have a duck in. The more recent ones, at least. I think it's funny. Okay, so let's see. If I what I'm gonna do is remove the scene. Yeah, so I'm gonna just remove this from everything, because I don't want to see the any of the rocks or whatever. So while we do this, so this is what we're interested in. Now when I press 0, okay. Now if I press it loads. I'm just pressing it over and over again. Let's check that we're not deleting the wrong one. Okay, so this is the other one. So what's happening, as far as I can tell, is that is getting moved to here. It's getting deleted. So let's try removing the other one. This is why I wanted to turn this off, because the rock was getting really confusing. So let's delete the second one. So that's the one that's moving in front of us. Yeah, you might be right. Let's I'll do that in a minute. Reduce the scene down to 5 and we'll see what's going on. Wait, there's a duck. I think you could use, I don't know what WGPU is. It's like Vulkan, but easier to set up. Okay. I'm telling you that the Vulkan drove to the NVIDIA store to get a rebar. Yep, I'm sure it did. Right. Okay. Right. So I think it's going to delete this one. Let's stop moving. Yeah. Let's do what. Let's reduce the scene down to like basically nothing. To like 5. We can easily do that. That's not hard at all. Which is quite easy to do, because we just change this number to 5, and now there'll be 5 things on the screen. Okay. Oh. Okay. What was happening here? Oh, right. Okay. I have to be careful from delete. I'm being dumb. I deleted everything from the scene when I did that. Okay, so this is kind of fragile. We've got to be careful not to delete. Right, we did delete one delete swap. Now, what I'm also going to do is just change the movement, because it's kind of awkward at the moment. To see one that's going down and one that's going across. So let's improve this, make the scene easier to debug. And so we're going to move them in the same direction, probably slower though. Like -4. So it's extremely slow. I think they're in 2 different positions, so it should be okay. They're not going to overlap. Okay. Oh, wrong. Sorry. Didn't mean to do that. That's 0. That's -4. So that goes in front of us. I did the wrong values. Yes. Yeah. Totally. Yeah. Now I understand what's happening. I'm using delete swap over and over again, which means that whatever gets put in the second place is okay. Where's the other one? Oh, there it is. One more check. I do use MSVC and GCC or G++. Okay, pressing 0. So this is 0, 1, 2, as far as I can tell. Right, I'm gonna end it here, guys. If you want to join my Discord, it's yes, it's well, I use GCC with the C++ runtime library. So thank you all for joining us on this stream. I will work on this off stream. I think this is more important than 2D rendering. But unfortunately I can't stream much longer. Time has come. I would like to keep streaming, but that's all we can do. Thank you for honestly, thank you for all the help. Honestly, I very much appreciate it. If you want to join my Discord, it's in the but again, you have to be older the age of 13 to join Discord, right? Wait, hint. No, but I very much appreciate everyone turning up, honestly. Right. Sorry, that was a bit mean. I will end it here. I will all see you soon. Thank you for anyone who likes and subscribed as well. Appreciate that. And yeah. Bye bye.